Okay, so we want to find the distance between these 2 points on a polar grid. That's what we want to do. We have already been able to find the distance between 2 points on a rectangular coordinate plane. Remember doing that? Yes? Okay, that's something that may have been introduced to you in Algebra 1. At the very least, everybody did it in geometry. But let's say I have you don't have to draw this, but I have a rectangular coordinate plane, and I want to find the distance between these 2 points. So you have a distance formula that looks something like this with the x1, x2 stuff in there. Remember that? I mean, even if you couldn't tell me what it is, remember doing something like that. So let's say you don't remember this, which most of you probably couldn't rattle it off to me correctly, and that's okay. What's another option to be able to find the distance between these 2 points? How else could you do it besides having to know this? Okay, well, how are you going to do that? Slope is not going to help me any, necessarily. Okay, but you do make triangles. Like, I mean, you basically, it kind of looks like slope. I think that's why everybody says slope. But if I find this distance here, and I find this distance here, then what can I do? Pythagorean theorem. Yeah, it's Pythagorean theorem. If you can find, because you can count horizontally and vertically on the coordinate plane, right? So it's just, you can get Pythagorean theorem. This distance formula comes from the Pythagorean theorem. That's why you can use it if you don't know what it is. So in the polar coordinate system, it's not Pythagorean theorem because it's not all rectangular. Instead, it is connected to the law of cosines. Okay? So here's this circle here. I want you to leave some space, and then we're going to write the law of cosines. There were 3 versions, right? And they all pretty much did the same thing. The letters don't even really matter because they're never those letters when you do it anyway. But one of the versions look like this. A squared equals b squared plus c squared minus 2bc times the cosine of a. Remember doing that when we did law of sines and law of cosines? Yeah, and so we have this triangle here that's not a right triangle. This would be us looking for a, this would be angle A, right? So then this could be B, angle B, C. So in order to find the length of A, that's what we would be looking for, we'd have to know angle A and these 2 side lengths. We substitute all that in, boom, we get A. Okay? That's how we found the missing side of a triangle that's not a right triangle. Make sense? So on the rectangular coordinate plane, you would draw perpendicular and horizontal lines so that you could make that little right triangle. Here, we're not trying to make a right triangle. Instead, I would connect these 2 points that I want the distance between, I would connect them to the pole, like so. And it's possible that could be a right triangle, but that's not always going to happen. And on my board, I can't read. Okay, this is P1. I have little subscripts I can't read up here, in P2. And I want to find the distance between those 2 points. Well, the way I plot this point is I have to know this angle and this radius, right? So this R1 theta 1, this length right here is R1. Make sense? So what's this length? R2. And then this, I need this angle. Well, from 0 to here is theta 1, and from 0 to here is theta 2. So how do I figure this part out? If all the way to here is theta 1, and all the way to here is theta 2. Theta 1 minus theta 2. Okay, you just subtract that one off, and then you just have that angle there. Does that make sense to you? And so the 3 pieces that I would need to find this distance, which we'll call D for that distance, I need to have these 2 side lengths, which I would know in this case, I would have the R theta for each one, and this angle, which I can figure out from that as well. So if I just take this stuff and I substitute it in here, I'm looking for A. Well, A would be like that D, so it's D squared, right? That's equal to B squared, which would be like R1 squared plus R2 squared minus 2 times R1 R2 times the cosine, oops, that's not an O, the cosine of this angle right here, which is theta 1 minus theta 2. Sorry that it's kind of going over into that example. But do you see how I just substituted all that stuff in? Do you understand where everything came from? That's just the law of cosines. And that gives me the distance. Now in the formula, we don't want D squared. We just want the distance. So we take the square root of both sides, and we get that the distance is equal to, big old square root, R1 squared plus R2 squared minus 2R1 R2 times the cosine of, and instead of theta 1 minus theta 2, I'm going to put theta 2 minus theta 1 because that's actually how you would see it on a formula chart. We'll talk about whether or not it matters here in just a second. Okay, so before you ask, no, you're not going to have to memorize that. All I want you to know, you have to know how to use it, and I want you to understand that it comes from the law of cosines, okay? And when we actually did this for Pythagorean theorem. To get the side lengths that you needed for those triangles, it's x1 minus x2 or x2 minus x1, but it didn't matter which way you subtract it because you were going to square it when you put it in there. So if you subtract something backwards, all that changes is the sign. It's the same value, but the sign's different, right? Here, we're not squaring that. So we'll look at whether or not that matters here in just a second. Otherwise, these become very simple problems. This is just plug and chug. You got the ordered pairs, you got the formula, you substitute it in, and you move on with your life. So we want the distance between these 2 points. So this is r1 theta 1, r2 theta 2. D equals square root. Well, r1 is 2 squared plus 3 squared minus 2 times 3 times the cosine of theta 2, which is 7 pi fourths minus pi thirds. Okay, now don't touch your calculator yet. Don't get ahead of me because I want to explain some things to you. When you substitute stuff in like this, first of all, I know you know what 2 squared is, and I know you know what 3 squared is. But first step is zero work. You substitute it in. That's all you do. That is process, and that can be a point on the AP exam or some credit on a test or whatever. So then we're not doing anything else by hand. Even in the calculator, I know you know what 2 squared is. I know you know what 3 squared is. I would suggest putting it in there just like that. The other thing is when I write it, I prefer to have the parentheses here because otherwise my minus signs, my multiplication signs might look the same sometimes. But in the calculator, I wouldn't be doing parentheses. Please don't be on the calculator yet, like I said. So I wouldn't put the parentheses. That's a lot of stuff. I would put multiplication, but be careful. When we get here, I'm going to have you do something again. Even if this is easy to subtract, I wouldn't. Let the calculator do everything. So you're going to get one person from your table, you're still not going to type anything in yet or you might regret it, that I want somebody to, I didn't mean it like that, I want you to subtract this backwards, meaning pick one person at your table to do pi thirds minus 7 pi fourths instead of doing it in this order, okay? But you have to double check on this calculator, start with the square root so it does everything. But you got to make sure it's in the right mode because it may not be because we've been switching back and forth in the other classes. So just in case, let's just show you what to do. And even if it says R, you're not sure, this is how you change it. Do shift and then mode, which is right next to on, and then pick 4 for radians. That way you know you're in radians. Even if it was already in radians, it didn't hurt anything, okay? But if it might have been in degrees. So you make sure it's in radians. Make sure you have one person at your table that's going to type it in backwards. Go ahead and type all that stuff in, okay? Well, if he's going to do it, then you're good. Yeah, go ahead and type it in. I would start with the square root, do it all in one step. Even when you get to this part, right here, you can use the fraction button so that you can make the fractions look decent there. Yeah, pi's down there at the bottom under the scientific notation one.
Was that revolved? Well, I was supposed to pick clear instead of I would have done that.
All right, so what did we get?
I did my backward right now.
You got 4.01. What'd you get? What'd you get? What'd you get? All right. We all agree on 4.01? Yes, yes. And it says to the nearest hundredth, so it is 4.01. So whether you subtracted backwards or not, it didn't matter. All that happened was one of the angles was negative. But here's why that works. Because remember this. What is the I did almost fall. The cosine of negative theta, what is that? It's cosine of negative theta is the cosine of theta, right? Remember that off the chart? That's why. Because whether you got the negative angle or the positive angle, you got the same cosine value. So there's no squaring involved, but the values are the same, and that's why it didn't matter. It's not, it's not that the calculator knows this, it's just that you know it too. Like, what's the cosine of pi thirds? No, good. It's 1/2, right? The cosine of negative pi thirds is also a positive 1/2 because in the fourth quadrant, cosine's positive. Does that make sense? It's not a calculator thing. All right. So are we good on this? Yes? All right. So then let's do the next one. We got d equals, and we're going to substitute this in, and I get -1 squared plus 5 squared minus 2 times -1 times 5 times the cosine of 2 pi thirds minus 11 pi 6. And nobody has to type it in backwards because it's not going to matter. So go ahead and get that. Make sure you can type it in, and let's get the right answer, and then we will move on. Let's be nice. Here, I'll put the right answer up there, and then you got to make sure you can get the right answer. Okay. Okay, so if you got an error, it may be that you forgot to end the parentheses, because you have to close those parentheses, or it's not happy. Or it might be something else, but just letting you know. Actually, there's two different things that'll happen. If you got an error, either you didn't close these parentheses, or you didn't make that -1 there. Maybe. Okay, so let me remind you of this also. -1 squared is different than -1 squared. And so here's another thing about this. Let's just think calculator skills. Now, when you write it in here, you have to write everything just like it looks, right? But when you're going to square a negative number, isn't it always going to be positive? So when you type it in the calculator, if you make it positive, that's fine. If you put it positive there, it makes it wrong because where'd you get the 1 from? But that way you can kind of eliminate some negative issues there. Okay? So if anybody else, yeah, so that's your issue there. Yeah. Okay. Did you get the right answer? Good deal. And if anybody else did it, make sure you can. Let me help you figure out if you don't know why, because I don't want you not getting something right just because of the way it's being typed in the calculator. We're all good here? Are we all good here now? Yes? 1 second? Okay. Okay. All right. Once you've... Well, let me see what you typed in. Well, if you've got this, go ahead and get your notes out that I get today. Oh, goodness. Okay. It's because I don't know how to undo it. You put the fraction in the fraction, and I'm not sure how to undo that without deleting all of that. There you go. Okay. So we're not doing the last two examples. So once you've got that, we're good on that. Okay. And we're not going to need the calculator for today's stuff, so you're good on that. All right. We are moving on. I already forgot, and I just looked at it. 127. Okay.
So there's no unit. It's just.
There's not a unit there because the units would be whatever the radius units are. So like if the radius was 5 inches, that would be in inches. But since it didn't give us anything, that's a good question. Then we just don't care. Yeah. Yes. Good. So yeah, some things it really should be like units. It could be chickens. We don't know. I don't know. Yeah. Okay. No, we're not going to do those two. We would leave it in degrees, though. That's why our calculator was changed from degrees to radians. We were changing back and forth, but we're just not going to do those because I don't have time. All right, so let's look at some basic polar equations. I'm going to show you some other polar stuff too, but we're just starting with the super basic equations today. Remember graphing in an x and y coordinate system, the easiest lines to graph are x equals and y equals, right? Okay, and those are the ones we get mixed up the most, but they're the easiest ones. So what we're starting with is kind of that version in polar. They're not necessarily lines, but it's like the easiest thing we could possibly do. So a polar equation is an equation that's expressed in terms of r and theta, obviously not in x and y, right? So we could have something that looks like r equals 5, or theta equals pi halves, or r equals 3.5 cosine theta, that kind of thing, okay? So those are just some examples of what polar equations could look like. So let's think about when we graphed the line y equals 2, right? So just in the rectangular coordinate plane, y equals 2. Well, if y equals 2, that means it doesn't matter what x is. Whatever x is, y is always 2. That's why you get a horizontal line, right? And so when x equals 2, it doesn't matter what y is. The x value is 2 no matter what y is, yes? So here, if the radius is 2, so if my angle is 0, my radius is 2. If my angle is pi fourths, my radius is 2. If it's pi halves, it's 2. If it's 5 pi 6, it's 2, right? 7 pi 6 is 2. So what you get here is literally a circle with a radius of 2 when r equals 2. That is r equals 2. Easy enough? All right, so then on number 2, yeah, you literally just draw that circle. You've got r equals negative 4.5, okay? So if I'm at 0, my radius is a negative 4.5, which would be like right here, okay? And then if it's pi thirds, rather, then it's negative 4.5, right? And then if it's pi halves, it's negative 4.5. Is it really going to be any different than the circle with the radius of 4.5? No, it's not. You just kind of are starting in a different place. But eventually, you're going to get all those in there. You don't have to plot them all, but I'm going to plot a few more, so maybe my circle can actually look sort of circular. Yeah. Okay, there we go. Okay. Everybody good? Yes? All right. So now let's look at number 3. On number 3, it says theta is pi thirds. So here's pi thirds, right? If my radius is 4, my theta is pi thirds. If my radius is 6, it's pi thirds. If my radius is a negative 2, it's pi thirds. Or a negative 6 is pi thirds. Or 0 is pi thirds. So what am I going to get? A line. It's a line that goes through pi thirds. Now, it also goes through 4 pi thirds, and that's the question I get a lot. But that's because this is basically the diameter of the circle. And so if I'm still on pi thirds and my radius is negative, that's why I come down there. But it's a line. Okay, we good? So you try and graph theta equals negative 7 pi 6. Negative 7 pi 6 is a coterminal angle with what? 5 pi 6. And so it's a line that goes through 5 pi 6 that looks like that. Okay? We're good? Negative 7 pi 6. You go clockwise. Yep. Like that. Yes? We got it? Any questions? And there's arrows on the ends because it's a line.
What was that?
It's a line. You put arrows on it. All right, so let's look at a more complex graph. So it says to graph the equation below, we're going to plot the points using a table. We're going to fill out the table on this one. We're not filling out a table on every single one of them. Just the first one so we can really look at it and think about what's happening. Then we're not going to have to on the rest of them. You'll see why it's not necessary. So if I have r equals 2 times the sine of theta, right? So I substitute these in for theta. When theta is 0, what's the sine of 0? What's the sine of 0? 0. Sine of 0, 0. 0 times 2 is 0. What is the sine of pi sixths? 1/2. And 1/2 times 2 is 1. Okay, so then I go to pi thirds. What's the sine of pi thirds? Square root of 3 over 2. And square root of 3 over 2 times 2 is? Yes, 2 square root of 3 over 2, which is the square root of 3. Then pi halves. What's the sine of pi halves? 1. Sine of pi halves is 1. Times 2. Oh, shoot. Times 2, which is 2. Thank you. 2 pi thirds. What's the sine of 2 pi thirds? Is sine negative in the second quadrant? No. All students take calculus, right? So pi thirds is square root of 3 over 2. If it's positive in this, so it's square root of 3 over 2 times 2 square root of 3. The sine of 5 pi 6. Well, the answer is 1, yeah. So it's 1/2 and then multiply by 1, so or multiply by 2 and get 1. All right, so what's the sine of pi? 0. Okay, so since both of these pi 6 angles are 1, this is 1, but we're in the third quadrant, so it's also what? Negative. 4 pi thirds, that'd be a square root of 3, but it's going to be negative. This is going to be a negative 2, negative square root of 3, negative 1. Now, what's not on here are the pi fourths angles, and we're not going to fill them all in. We're just going to do one of them. What's the sine of pi fourths? Square root of 2 over 2. And then when I multiply it by 2, I get square root of 2. Okay? So in order to plot some of these points, we're going to need to estimate, and we'll talk about estimating in just a minute. But we're just going to go ahead and plot the easy ones, right? The ones that I don't have to worry about the square roots on. So I'm going to go over here. When theta is 0, r is 0. When theta is pi sixths, r is 1. So I'm going to skip over pi thirds for a minute. We're going to go to pi halves. When it's at pi halves, my radius is 2. When I'm going to skip over the square root of 3. When I go to 5 pi 6, my radius is 1. Skip over the other square roots. So when I'm at pi, my radius is 0. When I'm at 7 pi sixths, my radius is negative 1. I already have a point there, right? When I'm at 3 pi halves, my radius is negative 2. I already have a point there. 11 pi 6, my radius is negative 1. I already have a point there, okay? So these right here are all just repeats because I already got everyone went all the way around. Now, just by these 4 points, you don't have a clue what this is, okay? And that's okay. We gotta graph the other ones. So what's going to come up over and over again are square root of 3 over 2 and square root of 2 over 2, right? So you need those estimates in your head so that you can multiply them by 2 or do whatever you got to do. So square root of 3 over 2 is about 0.9. You would never write that as an answer or substitute that in to solve something because that's just a rough estimate to help us graph something. And then square root of 2 over 2 is about 0.7. Okay. So when I go back over here to pi thirds, this is square root of 3, and this is square root of 3 over 2, so I'd have to double this. That's like 1, right? It's like 2 times 9, so 18. So at pi thirds, I am at about 1.8, which would be right about there. When I'm at 2 pi thirds, I'm also at about 1.8. And then as I go around, that would just repeat those. So then we look at pi fourths. Pi fourths is square root of 2. So square root of 2 over 2 is about 0.7, which means this is about 1.4. So I go to pi fourths, and 1.4 would be right about there. So when I go over here, it would be right about there as well. Now, this kind of looks like, and there is symmetry there, yes. It kind of looks like it expands from the bottom, but it doesn't. What does it look like maybe it could be? It's a circle. And I know that this kind of plays tricks on you. If we plotted the pi 12ths angles in there, then it would definitely look more circular. We're not even going to plot that many points when you actually plot them. You're going to plot some key points, and then you're going to just do your best to make it look circular. Even when we do it on the rectangular coordinate plane, they still look like eggs in footballs. So we just, do the best we can to make it look like a circle, and we go from there, okay? Everybody okay with that? So again, the chart is not something we're going to fill out every time. It's not necessary. I will walk you through how to do the rest of them, okay? So let's flip it over on the back. So now I have r equals cosine theta. So instead of making a chart, we're just going to think our way around the circle. So at 0, what is the cosine of 0? 1. And you have to know these values, by the way. Then you go to pi 6. What's the cosine of pi 6? Square root of 3 over 2, which is about 0.9. So we have to put about 0.9 there. Then we move on to pi thirds. You can even skip over pi fourths if you want. So pi thirds, what's the cosine of pi thirds? 1/2, right? And so I go to 1/2 because this is every 1/2. Pay attention to the scale because these can change on you. And then I go to pi halves. What's the cosine of pi halves? 0. What's the cosine of 2 pi thirds? It's negative 1/2. So over here at 2 pi thirds, negative 1/2. So I'm down here. And then I got to go to pi 6. Cosine of pi 6 would be about 0.9. And then you've got a circle that's touching the pole there. And the smaller they are, the more like a circle it actually looks because the points are a little bit closer. Okay. Questions? Yeah, we got a -3, and we'll work on that one today. Any questions at this point? All right, so let's look at number 7. We've got sine of theta, so 0. What's the sine of 0? 0. So that's just 0. Then I go to pi 6. What's the sine of pi 6? 1/2. So I multiply that by a -3. That's like a -1.5, right? So at pi 6, I have to pass through here, and I go to a -1.5 right there. Everybody with me? Stop me if I've lost you. Then we'll go, I lost you? Okay. So we go to pi thirds. What's the sine of pi thirds? Square root of 3 over 2, which is about 0.9, right? So 3 times 0.9 is 2.7, but it's negative 2.7. So it would be down like this. Okay. Then at pi halves, what's the sine of pi halves? 1. At times multiply -3, I'm down here at -3. Now, this is their symmetry, right? So instead of thinking about the other ones, I can use that symmetry. So here at 7 pi 6, 11 pi 6, I've got a point there. 4 pi thirds, 5 pi thirds would be that right there. And then you just do your best to make it look like a circle. This is not an art class. All I want is an honest effort and not something just slopped on your paper. But don't, spend forever trying to make it perfect either. It's not necessary. It's understanding the concept is more important. Okay. Are we good? Any questions? All right. We are going to move on to number 9 then. So this is the cosecant, right? This is the reciprocal. So cosecant is a reciprocal of what? Sine. So this is r equals 1 over sine theta. Okay? So I'm going to think about things in terms of sine, and then I'm going to take the reciprocal before I plot it. So we're going to start at 0. What's the sine of 0? 0. What is 1 over 0? Undefined. So I have nothing to plot at 0 because it's undefined. So I'm going to move on to pi 6. What's the sine of pi 6? 1/2, right? So what's the reciprocal of 1/2? 2. So at pi 6, I'm really at 2. Okay? Pi thirds, well, that's the square root of 3 over 2. And I know that's about 0.9, but the reciprocal of 0.9, I don't know, and we can just going to see if maybe we can skip that for now. So let's move on to the next one. What's the sine of pi halves? 1. What's the reciprocal of 1? 1. Okay? So at pi halves, I'm still at 1. So I plot 1. So 2 pi thirds, that's the square root of 3 over 2 again. We're going to see if we can skip it and get away with it. And then we're going to move on to 5 pi 6. What's the sign of 5 pi 6? The sign of 5 pi 6 is 1/2. It's a positive 1/2. The reciprocal of that is 2. So at 5 pi 6, I am at 2. So what does it look like is true about these 3 points? Makes a line. And it does. That's why the other points don't even matter. This is a horizontal line that looks like this. Bam. Okay. So when you do the reciprocals, you can just use the nice decent values. You can like skip over the other ones and it'll give you some other points. Okay. We good with that? So let's do number 10 together. So number 10, I've got 1/2 times secant theta. So that means r is equal to 1/2 times the not times the cosine, times 1 over cosine of theta. I don't even care about them. Don't even try and multiply them together. Just do the cosine and find the reciprocal and then multiply by 1/2. So what's the cosine of 0? 1. What's the reciprocal of 1? 1. So 1 times 1/2 is 1/2. So at 0, I'm at 1/2. What's the cosine of pi 6? Square root of 3 over 2. Yuck. What's the cosine of pi thirds? 1/2. So what's the reciprocal of 1/2? 2. And what's 2 times 1/2? 1. So at pi thirds, I'm at 1. What is the cosine of 2 pi thirds? No. Cosine of 2 pi thirds is negative 1/2. And the reciprocal of that's going to be a negative 2. Negative 2 times 1/2 is negative 1. So at 2 pi thirds, I'm at a negative 1. And then this is a vertical line. Yeah. Well, none of these are functions, but we don't talk about functions on here. Okay. We good? Okay. Everybody okay with those? All right. So now what I want you to do is I want you to go back and do number 8 and also do number 11 on your own. Okay? 8 and 11 on your own. Oh, give it over yourself. And on your assignment, you just have 6 easy. Okay, so listen, guys. When you're doing this one, so the cosine of 0 is 1. 1 times 4 is 4, right? So then when I move on to pi 6, the cosine of pi 6 is the square root of 3 over 2. Don't substitute it in there and reduce it. Remember that the square root of 3 over 2 is about 0.9. 4 times 0.9 is about 3.6. Okay? So 3.6. So that's the easiest way to do this. All right? Remember, you would never write down 3.6 as that. And then we move on to pi thirds. Cosine of pi thirds is 1/2 times 4 is 2. And then pi halves is 0. And then you just repeat those down there. Symmetry. Mm-hmm. Mm-hmm. And on number 11, it's going to go off the circle a little bit, and that's okay. I'll show you what to, no skip. Come on, graph, people. What you think I said? When the sign of 0 is 0. 1 over 0 is undefined. I have nothing there, right? So I go to pi 6. The sign of pi 6 is 1/2. The reciprocal of 1/2 is what? 2. So 2 times a negative 2 is a negative 4. So I'm here at pi 6. I go to a wait a minute. Yeah, negative 4. It's like way out here, right? But look what happens. So if I just extend this, just like you would extend any other graph, you don't have to draw circles and stuff. I'm here. This is at 3, so this is about 3.5. This right here is about 4. Okay. So then pi thirds, the sine of that is going to be square root of 3 over 2. I don't want to do that. So pi halves, the sine of pi halves is 1. Reciprocal of 1 is 1. Times a negative 2 is a negative 2. So my radius goes down here to negative 2. I get that point. And then since you've got symmetry, I would definitely extend that line, because if not, there's no telling where my point would be. But you got that. So you've got your 3 points, and you can draw your line. Okay. It takes 2 points to make a line, but as when you go outside of it, you might want to make that third one there. Okay. Everybody good? Yes? These are not that bad. You've got 6 to do on your assignment. Get them done. No excuses. You've got some time left. Yeah, it's a lot better than 60. I didn't really say 60. I said 6 easy, but it sounded like 60.